Let's look at the ARP, Address Resolution Protocol. Now, if you're using IPv4, we know that there's got to be a way to map IPv4 addresses to MAC addresses. And every device in the Ethernet network has a unique MAC address. Myself back in here, I can see what's going on. And what you're going to have to do is say, hey, I need to figure out what that MAC address is, because I don't always know what that MAC address is. So in some cases, you've got a device that you're trying to send to, in this case, H4, and you don't know what address, you know the IP address, but you don't know the MAC address. So what the device uses then is called Address Resolution Protocol to determine that destination MAC address. And then this Address Resolution Protocol kind of forms two different functions. One, it resolves IPv4 addresses to MAC addresses, and then it maintains a table of IPv4 to MAC addresses. So it kind of does two things to keep track, so it doesn't have to do this every single time. So some of the basic functions of Address Resolution Protocol, we know that when a packet's sent, the data link later encapsulates it into the frame. So what the sending device will do is it'll first check its Address Resolution Protocol table, the ARP table, to see if the destination IP address and MAC address exist. If the packet's destination is on the same network as the source network, it'll search the ARP table and it'll go ahead and use it. But if the destination of the IPv4 address is on a different network, then it must search the ARP table for the IPv4 and of the default gateway, because the default gateway is telling you how to get outside the next to the next device. It says, because I don't know about it, I need to have somebody else. What's my destination of last resort? What's my one way out of here if I don't know it? And that's what your default gateway is. It says, I don't know it. I'm going to forward you on to somebody. Hopefully it does. Now, every row, every entry in the ARP table kind of binds the IPv4 address and a MAC address, so that you only do this lookup once, and it kind of saves on processing speed and time. Now you can look at the video here and watch how it does that, and I kind of recommend you do that, because when an ARP request is sent, a device needs to determine the MAC address is associated with an IP. If it doesn't have in the ARP table, it's got to say, hey, I don't know. So what does it have to do? It has to send out what they call a broadcast message. It kind of says, hey, I don't know the MAC address, so I'm going to send it out to every device, except the one that is making the request, so versus the incoming packet. And that MAC address, because you got to have an address, is all Fs, as you can see. The source MAC address is the MAC address of the sender, but the destination address is all Fs, and that tells me I'm going to flood out this message now. I'm making a request to everybody on the network to tell me, does somebody know the MAC address of this IP address? And it floods out every port except the receiving port, the one that was coming in. Now, and then every other receiving MAC looks at it and says, hey, I don't know. And then once it says, hey, I found one that matches my IP address, I'll send you back the address. Now, one thing we have to keep in mind is routers, switches will forward out a broadcast message all day long. Routers will not forward broadcasts to any other interfaces. So if you got a router in your network, it'll get it, says, okay, I'm not doing anything with it, leave it alone. Once you get a LAN that matches the IPv4, then that address, it'll reply with an ARP request saying this is what the MAC address is. Now, I go ahead and watch the video if my computer would back up. Just watch that video and showing you how that thing does it. Now, in that video, you're going to see that you got a destination MAC address, and it's got the sender MAC address. Now, any kind of ARP requests, you're going to have a field type in that frame of a hex 0806. And pretty much that informs the receiving NIC that the data portion of the frame just needs to be passed on the ARP process. So you don't have to worry about having a lot of other things going on. I'd go ahead and watch the ARP reply. The communications between the two, it basically says, hey, once you've got an IP address that matches my device, I will send back my MAC address, and that way you can update your table. Now, the entries in an ARP table don't stay there forever. They're on a timer. So there's a cache timer that removes entries after some period of time. Some cases, like the newer Windows operating system, entries are between 15 and 45 seconds. So they don't stay there very long. But at least, because it's still making the assumption that, I'm sending messages, I'm probably going to send a message to that same device for a longer period of time, so I don't have to keep updating this material. So you've got the table, the address, and a timer going on to tell me when I remove that device. Now, if you do in a router, you can do show IP ARP, and it'll show you the contents of the ARP table. You can also do it on your PC at the command prompt with the ARP-A option, which then tells you all the physical addresses that it knows about the internet and the MAC addresses that it knows about. As you can tell, some of them are dynamic that change on a constant, and some are fixed. Fixed because they're special use IP addresses, so you usually can't change them or modify them. Now, there are a couple issues with ARP. One is ARP broadcasts, and the other one is ARP spoofing. Because I am broadcasting out to everything on a shared media, you can put a lot of information on that network, and sometimes that becomes an issue. So just be careful that you can flood it too much. I'm making a request and it keeps getting sent around. The other piece is if I'm spoofing, if somebody got into your network and they can pretend to be the default gateway. And what does that mean? I'm capturing all your information, all the replies that are being sent back and forth, and of course, stealing vital information. You are going to do the 2.9 examining an ARP table, and then I go ahead and have you do the understanding part, just to make sure you understand a little bit how to use MACs. Now we're going to move over to the next video with IPv6 neighborhood discovery. See you in a little bit.